So I'd like to address three issues that the committee would like some input on. One is sort of the culture of open sharing. One is our concern or an issue about what we might call rogue science. And then the last is metrics of sharing. And we'll try and do that quickly and then leave some time also for the committee members to ask questions. So, Atul, I just wanted a clarification. You said that each of the projects have their own policies that you just then help them implement. So is this an open model? Like, is that the assumption? And then what are the bounds within which each project can shape their data policy?
Yeah, so the question about their own data sharing policies, we don't write their data sharing policies. So it's something that they come up with within their consortia and in collaboration with the NIAID program officers. So some program officers tend to be really stronger about wanting some data to be shared. Maybe it's written into the RFA that they apply for, maybe some aren't. So in general, most of these organizations, these consortia, share their data when the publication's released. And some of them share data within their consortia before the publications are released, another alternative model. But even the time frame there is not clear. If a trial fails and no one's going to write up the paper, it's still ambiguous whether that data ever becomes publicly available, whether it's NIH funded or not, like who's going to take the effort to do it.
So this is negotiated for each project?
That's right. Typically, I think it's negotiated for each project. As you all know, NIH policy, if you apply for more than $500,000 a year, you have a data sharing requirement. But in my experience, it's been hard to enforce those data sharing policies.
Right. So have there been pockets of resistance to a more open, and sort of is getting at this issue, I think, that you need to build in the culture sharing from the beginning. Have there been pockets of resistance that you've encountered, and how have you?
Yeah, absolutely. There's a culture of resistance. So I think some of it is timing. So we're asking people to share data that was generated 10 years ago before people were even thinking about sharing data. So in some ways, there were skeletons and we're going to see them now, and they weren't maybe expecting that. So moving forward, one would ideally hope that that gets better. But there are these challenges of authorship, about finding. Some investigators still think they look poor to others when they didn't ask a critical question. And I think that culture has to change, whereas if someone else comes up with a creative question on your data, that should be celebrated, and the original data collector shouldn't be really disrespected in any way. It takes credit. They should get credit for that.
So I think there's more of that culture in sharing biological data. And John, you're very familiar with that space. What would you say about sort of the challenges of moving what you've learned from sharing in the biological domain to the clinical trial domain? What do you see there?
Well, I mean, I think to Tul's point, the legacy problem is one that can't get solved other than through sort of facilitated, controlled data access, which is something to be celebrated, not something to be criticized. Not everything has to be open. The rationale to have some stuff past these definitions is that you know if you have the data that's past the definitions that you can combine all of that open data into one thing, and you're not going to have sort of counteracting contracts. But in almost every space where you have truly open systems, the vast majority of people who are sharing under more controlled circumstances. So in Creative Commons and culture, the vast majority of the users use a non-commercial license, not the ones that pass the open definitions. But at Wikipedia is built solely on guaranteed open content because that allows the recombination that makes Wikipedia scale. So the key is to provide the tools and the advice and perhaps the IRB training so that the people who do want to do open access systems are able to do so in a relatively easy way. And then to provide guidance and rules that say here's how things that don't quite meet the open definitions can be cobbled together and used to do meta-analysis and reanalysis. Because the value of the open stuff in the biology space is you have reference data sets, you have baselines against which you can calibrate software models and other sorts of things, and you can bootstrap without asking a lot of permissions. But once you get very far, you start asking for permission to access dbGaP, which is not open data. But it's still a tremendously socially valuable tool. And so it's thinking about sort of, you want to have these baseline systems so that those who want to truly be open, who are willing to go through the effort, can do so. They don't get derailed along the way. And then you want a clear way of how to pull those back into these more facilitated, controlled environments. Okay,
great. Great. So having not just fully open systems, but also partially open systems that can build into a system that's overall more open. Okay. We'd like to address the issue of what some people might call rogue science, where having data sets out there might allow anyone to do analyses, and perhaps they are, have scientific methodology that might not be defensible or maybe are, and how I wanted to ask both of you how you conceptualize a continuum of reuse from what we would all acknowledge as high quality science and what we all might clearly call rogue science. How do you think of that spectrum in between? Do you have examples of rogue science? How do you monitor it, and how do you mitigate it?
Yeah, so I'm grinning because on this coast it might be called rogue science, on the West Coast it's perhaps called citizen science. And I think, but that being said, I think there are certainly people who download data and actually make use of it. And whether it goes into a scientific publication or a product, for example, it's hard to really draw that line. I had quickly breezed through a product from a company called Pathwork Diagnostics. They're out of business, but they used microarray data from the gene expressionometers, public and CBI data, and they came up with a FDA-approved diagnostic for cancers that metastasize. You can figure out where the cancers came from. And so they're not traditional academics. They're not even close to that, right? They're a biotech company. Do you call them rogue, or do you call them actual scientists would be questioned. So I think there are people going to misinterpret data. I think if the data is really heading towards being publicly available, the right way to deal with that is to have maximum transparency in the way you analyze the data, right?
Have you had any examples in the import study of people who've done analyses, maybe from scientists, that either the original authors or import felt was more towards the road side, or less? Oh, sorry.
Yeah, the question is whether we've had experience in import with rogue scientists. I would really, maybe I'm reaching too much, but I think the original scientific depositors view us as the rogue scientists here. That we weren't part of these trials, and kind of how dare us look at this data again and even reinterpret it. So, but beyond that, no.
And just to follow on, I mean, so Atul took the best punchlines on rogue science. I mean, but rogue science, so not even discounting the citizen science, which I think is important, but like let's take actually malicious science, right? That's going to happen whether or not we have open data. There was a great story in Aeon magazine last week about a reporter who synthesized his own designer narcotic using available information in Google and the sorts of transaction systems we have available. Right? That's rogue chemistry, I think, under your definition. He didn't need open data to do that. I know people who practice rogue epidemiology and rogue pharmacology using the internet on a daily basis. It's very difficult to design any sort of system that allows access in a way that disables all the potential malicious uses. But the reality is that what are the externalities of any sort of system, and are the positive externalities better than the negative externalities? And I think in making the access available, the odds of positive externality are higher than the odds of novel negative externality, because I think most of the bad stuff's going to happen anyway.
So that brings up the question actually then of how either of your projects track sharing, track those externalities, either positive or negative. What are your metrics?
Yeah, so our metrics are pretty clear from NIAID. We need to get more people downloading our data and reusing it in new publications.
So it's publication. That's the bar.
That's a great
point. How do you track that?
Yeah, so we have identifiers for our data sets. We are moving towards something called DOIs, Digital Object Identifiers. I think most people understand that. So we can better track who uses it. Right now, you need to sign up for an account. It's a free account, and we can track who's downloading what. We don't really say no to anyone, but we at least use that login to actually track them. But our clear metrics, the more people who download data, better, more successful we're going to be. But it might be in a patent application, it might be in something else too. But I think being mostly academics, I think we're really counting Google Scholar citations of our identifiers would be one easy metric for us to show people using our data.
Do you track collaborations between people who are using your data sets for their downloading it and they're collaborating with the original authors?
We do not track that right now. Just to repeat the question, do we track the collaborators? No, not to that level.
And John, how do you track?
So we're a nonprofit, and part of what we do is not just broker data sharing, but provide a platform for people to do collaborative analysis. It's called Synapse. And so the fundamental organizing principle there is the project. So we track the raw number of projects. We have very detailed provenance tools that track the graph of how the data gets massaged along the way to a predictive model. And the goal is to provide an environment that is more productive for the scientists so that they have an incentive to stay inside the environment. Since you're not locked in by money, you're not locked in by IP because it's an open source platform with a nonprofit organization. We want you to be locked in because it helps you be more productive. And the early returns are that that's working. So the Cancer Genome Atlas was struggling to get papers out the first 9 months. They've deposited all their data in Synapse. They got 18 papers in the first 9 months that they had in there. We had 60 projects, 250 PIs, right, 25 institutions. And so once they got convinced of the productivity throughput, then it was easy to convince them to start staying in the environment and working in the environment. And the end game is ideally not just the papers, but all those little transactions internally. Like the one person in the TCGA who did all the annotations of the data turns out to be the most heavily linked to node in our graph. And that would not be exposed in paper citations. But now you see sort of this is a guy with a green thumb when it comes to making data that other people can use, and we've been able to find him in ways that would have been hard to find previously. It doesn't help us track malicious reuse, but it does help us create an environment where people have an incentive to stay inside the trackable system, because then they can start to apportion and receive credit.
And I'll open up the...
So, do you have any examples? Where data reanalysis has made a big and positive difference? I don't want to sound pejorative here, but the NIAID studies have not been any big ticket studies.
Right.
They've been small academic studies for very limited populations. So, maybe you should say always start small and work big.
Yeah.
So, are we making any progress to that? And do you have examples where the ability to share data has had a big positive impact, where we are someplace that we couldn't have been if it hadn't been?
Yeah, so you're asking specifically from the NIAID perspective, right? I'm at Stanford, so I can't speak for them. But I think there have been some small trials, and we have papers, some of the stories you've seen here now already submitted, and we'll see where they go. But I think, increasing the power of some of these by 4 or 5, if these are really if you can put them together, the meta trials, we might get better stories for some of these. So we'll have to see where the publications go. But my kind of role model publication would be just a paper came out about 5 months ago in Nature Genetics, well-respected journal, on a brand new oncogene, ApoBEC or something like that, APOBEC. And I love the first line of the methods. Okay, the first line of methods is we downloaded data from TCGA. Right? We didn't start with a pipetter, right? We started with the data, and because of that, they figured out this oncogene that's in, 16 of the cancers they looked at. So that would be my future model, because there's no reason why future trial papers couldn't start by downloading the data and figuring out something that was actually in all of these data sets.
All right. So when you do a clinical trial, you have a hypothesis that you're testing through intervention. The example you just gave us, where someone was finding something. So it's new discovery, not a hypothesis tested through intervention.
Mm-hmm.
And since we're kind of limiting our purview to studies where people are testing hypotheses through intervention, do you have examples in that setting?
Yeah, so you're right that they're testing an intervention, right? Typically, as academics, we get these funded, or we get them funded from the pharma or biotechs because there's a drug involved. But that being said, there are people also using hypothesis discovery methods in these studies. They're running microarrays, they're running flow cytometry, and others. So you're right, but there's also the other side of things. So a trial that might just look at, example, the one drug or the 2 arms might still have a lot of data being released that actually no one's ever looked at. So I think our stories are still early. I've been on Import for about a year now. I think we'll be submitting these as stories, but it's still early. I think the trial, we're in a chicken and egg here, where we didn't get a lot of trials data today.
One final question, and I'll stop monopolizing the floor. When you do a clinical trial, you only report a small fraction of the data that are gathered.
That's right.
In your agreements, do you put out all the gathered data, or just the data that really address the publication concern?
That is a great question. What exactly is released after the publication come out? We've seen it both ways. We've seen all sorts of ways. So there are, for example, these studies, the first year might have been reported, the first year gets released, but we know that they have multiple years. 15 panels of flow were measured. They reported on 1, we only get 1. So we've seen that model, but we've also seen organizations release all their data. Sometimes it's in their interest, as certain consortia get defunded because these go on for a long time. If they're getting defunded, if they don't release that data, typically it's lost for good. So it really depends on who feels like they own that data. In my experience, again, speaking for myself personally, when I see an IAD feeling that they own this data, then they get a lot of it released. Even if someone's in embargo, they don't want to lose that bite of data. When the consortium feels like they own it, then obviously it's publication driven.
Artie, I think. Let's see, we have Artie and then Steve.
So we've been talking a lot about individual investigators. What about the institutions, so the universities that may or may not feel like they have some ownership interest in the data, either that they submit to you or more generally? There's a long literature that I don't have to go into with either of you on universities being very grabby when it comes to data.
Yeah, so again, I can only speak from my experience. I think universities obviously can be grabby about intellectual property. I'm not sure how many of them still feel like a data set is worth anything anymore. We're in the microwave revolution, 15 years of generating huge data sets being publicly released. I think any of that is still moot because you can overcome that with the right agreements from the NIH perspective. So in the notice of grant award or in the request for applications, if the right text is written in there that you're expected to share the data, I think it's hard for institutions to get around that. John might have some comment about it.
Yeah, I mean, this has changed over the last 10 years that I've been working on this, from universities really thinking that data sets were of net present economic value to focusing more on the inventions that they can extract or the publications they can extract from the data. So as long as there are even some minor embargo periods or review periods before publication, typically we're not finding a lot of push on the data sets. The push comes more from, not from the tech transfer offices, I should rephrase, which is what most of the literature's on. The pushback we're getting is from libraries who are worried that they're going to have to support the openness of the data. So since we don't have anything that is as cohesive and comprehensive as PubMed for clinical trial data, this question of where are we going to put it, who's going to manage it, who's going to govern it, who's going to be liable if the governance is violated, those are the questions that get punted to the libraries who don't have the funding or the expertise to answer them. And so that's where we've found a lot more friction with universities than tech transfer.
Steve, and then I think we're probably out of time, is that right? And then Bernie will close out.
No, I thought we had 1:45. Yeah, right.
Oh, long question.
Yeah, no. So, well, the last point, John certainly teed up the work of our committee for the next year. So that's, I hope we can come close to addressing some of those things. So 2 questions, and this was brought up forcefully in a very first workshop. Right now, clinical trials, particularly big ones. So I'm not going to talk about the little, single institution or few institution trials, but the big ones, the incentives to, they're very expensive, they're very complicated, and for any investigator to go into them, it has to be borderline crazy, and yet we really depend on these being done. One of the academic returns on investment, and you know this well, is the publications. Right. So the question is, particularly for the completely open model, how do you mediate between, in a sense, the loss on that investment because they don't get the opportunity beyond a year or 9 months or whatever to mine the information in that data set? And this is acknowledging that some investigators are pretty slow about this, and they shouldn't get infinite amount of time.
Right.
But still, there's a huge potential loss of incentive to do the trials in the first place. And involve the number of people that they involve, that those people can't continue to get some form of credit. So how do you, one possible solution is the data set identifier and giving them credit for sharing, but it doesn't seem like that's a mature science yet. So I'd be interested in both of your perspectives on how you deal with this issue, because we don't want to kill the goose. We don't want to reduce the incentive to do the trials that we're all getting the benefits of sharing.
You're asking, this is a real risk for the academics here, and I totally acknowledge that, and I'm not going to win any friends for what I'm about to say, I think. But I think what you're also describing is a protectionism for this field of academia. And I think there are real harms from the data not being public, and the public even seems to get that. I think this is why it's in the press so often now that the trials are failing and the data is not being public. And there are perceived threats to academia. And at the same time, I can imagine if an investigator at my institution really finally decides not to enter the trial, I'm sure there are other institutions that are more than willing to go for those dollars to run a trial today. So it's a perceived harm, and I'm not sure if, again, with all due respect, I'm not sure if it's a real harm. But that has to be weighed here. You're absolutely right. So I think those that publish papers and the data, it really depends on who feels like they own this data in the end, right? If the government feels that they funded it, you can make a story that the data should be available to the taxpayers. If the individual worked hard to collect that cohort, the individual might feel like they own the data, consortia, even the university. So I understand it's a difficult decision, but there are, at least the public feels there's real harms here by not making this data available, and there are perceived harms, I guess, from academia. But maybe it's a flippant answer.
Right, and so maybe I'm going to take 2 perspectives. One is inside the system we have now, where it's expensive to run these kinds of studies the way that we run them. First, I think an embargo period is a rational way to balance some of those things. And then second, at the end of the embargo period, the reality is that the creator of that data set is more able to reanalyze that data set for secondary uses than a third party. Right? There's a ramp-up period to get comfortable with the data that exists that is a second embargo, if you will. And this is why in astronomy there's a sort of there's a normative concept that data coming off of the Hubble and other big space instruments is open immediately after coming off the instrument, but then there's sort of a gentleman's and gentlewoman's agreement not to poach it for 6 months. And that can be policed quite easily through norms. But in this space, the actual metadata and annotation spaces are so complicated that there's a second embargo of just getting up to speed. Then the second piece is I think we should start thinking about a world in which perhaps we've structured these studies so that they are less expensive and complex to run. Because if you consistently keep building complicated institutions, then it will be hard to make the economic argument to make the data open. If you simplify some of the institutions' structures around running clinical studies, then the transaction costs are lower to share it as well. And so, thinking about umbrella IRB protocols, thinking about umbrella systems and technologies that make the data sharing easy. Thinking about a variety of things that make it cheaper and easier to do these studies will make it cheaper and easier to share them as well.
So we have Dave also had a question.
So you haven't said too much about why open and not partially. There's the comparison to the next three discussions. Yeah. So now's your chance to sort of say why you would favor this approach, contrast to the others that we'll hear about.
So from my perspective, I think if it's fully open, and what that even is defined as, we haven't really clearly stated here. But to me, the more open it is to more parties, I think the more science is going to happen, the more engineering is going to happen. If a kid in a class is able to download the data and finally learns how to analyze clinical trials data, if the medical resident or the medical fellow can download actual cases and how they're called, rejection or not, to learn from actual images someday, I think that's a benefit for all. I think the minute you have to sign up for data and get private access, you cannot, when the rights of what you discover are actually impacted downstream, maybe there's reviews of papers, maybe you're not allowed to publish, I think that's a harm to everyone involved. So I think I'm a proponent of fully open, whatever that means, but the most parties actually getting access to that data. And kind of answering Steve's other point, I think it's been written by others. It's controversial, but there are people that believe that if you put your data out open, you get more citations for your publications. So if we're looking for academic kind of value there, at some point, again, we can argue which accounts for more, but I think there's academic value in the citations. But so in some ways, the more people that can see that data and cite it, I think the better it is for everyone involved.
And so I think that there's the real value for this is going to come from an ecosystem in which there's some stuff that's really open and there's some stuff that's liberally controlled and some stuff that's very controlled and some stuff that's just completely closed. The value of the open part is, first, is it gives us a counterweight to the fully closed. Second is that you're going to get innovations out of the truly open stuff, some of which are going to seem very trivial, right? T-shirts with your genome printed on it, or music made out of your genome. But you're going to see really unexpected benefits out of the open stuff simply because people can take completely insane shots at it. And that's been enormously valuable in software. That's been enormously valuable in culture, which created economic, social, political value. And it just sort of strikes me that it would be insane to construct a sharing system that didn't have that as one of the poles. Simply because we want some of those unexpected benefits to come out of it. And the other is that it provides a guide point. It provides a bright line beyond which you can combine and recombine without asking for permission. Because to Jeff's question about things that couldn't be done without open, I mean, we don't have the unambiguous answer, right? No one would have predicted that Wikipedia would be the unambiguously beneficial outcome out of free culture before it happened. And it's the ability to recombine all of the pieces of content that are in Wikipedia legally that is one of the and then the technical framework that allows it to be done. Those two things are what made it happen. And so it's the ability to stitch this stuff together to do new things. And so having truly open things that can be stitched together, recombined, and surprising, right? That's what open gives us that we don't get from these partially controlled systems. The partially controlled systems are a very good way to protect the participants and to facilitate data access by people who are already inside the system. right? It will be a very utilitarian way to make the overall system work better than it works today. It is very unlikely to produce a complete phase change in the way that we do things. That's probably going to come from the open stuff.
Devin, you have a question?
I did. But I think you just answered it, John. Which is, it sounds to me, and you can correct me if I'm wrong, that you're suggesting that we not go to a one-size-fits-all model, and that we leave space for a range of models, including openness.
Bernie, do we think it's?
I was going to suggest for those members of the committee who want to ask a question from now on, put your, so that the moderator can tell who wants to speak. But Steve, you want to go? Thanks very much,
Thank you
John,
very much.
to